It's been 150 days since the moon has been on a collision course headed right toward Earth. As the moon gets closer, ocean tides are rising, our cities are being flooded and destroyed, volcanoes and earthquakes are erupting around the world, the moon's gravitational pull is getting stronger and wreaking havoc on our planet. But wait, how did we get here? Well, let's go back with just 1 year until the moon hits Earth. We'll take you through each major phase of its approach, detailing the consequences and figuring out if we have any chance at stopping it. 365 days, okay, the moon is ridiculously far away, 384,000 kilometers away for reference. The circumference of Earth is just over 40,000 km. Well, with this kind of distance you could fit every planet in our solar system in the space between Earth and the moon, so this celestial body has a long way to travel, but at this moment it's headed right for us. At first you probably wouldn't notice anything. If you were on an ocean beach, maybe you'd find the waves splashing up a little bit higher on the sand, a result of the moon's gravitational pull on our largest bodies of water. But wait, let's take a second. Why is the position of the moon so important to us anyway? Well, the moon plays quite a few essential roles in helping out life on Earth. We'll get to that in a second. But first, why does it stay up in the sky? Well, that's got to do with gravity. The moon orbits the Earth at a speed of over 1 kilometer per s. That's pretty good velocity, and I'm sure it would love nothing more than to roam freely throughout space. However, since the Earth is so much more massive, Earth's gravity pulls on the moon, preventing it from being flung out into space. But what does the moon do for us down here on Earth? Well, one thing it does is help stabilize our climate, more on that later. But if the moon starts moving toward us, instead of seasons changing, we might get extremely long periods of cold in the Sahara, and some extremely hot weather up in Canada. That one I wouldn't mind so much, but what I would mind are ocean tides changing drastically because of the moon's shifting. You'll see why soon. Oh, and I forgot to mention, at the speed the moon is currently moving, it would actually hit our planet in a little under 5 days, so let's slow it down and give us a year in order for us to have enough time to see if we can solve the problem. T-minus 300 days. Okay, the moon started 384,000 kilometers away from Earth. But now it's 250,000 kilometers away. With the moon this much closer, it's heavily affecting our oceans. Rising tides are reaching up to 5 m. This is flooding our coastal cities. Places like New York, Miami, London would all be underwater, buildings would be destroyed, and citizens would be forced to evacuate. But that's not all. Any animals that live on the coast, like sea turtles and pelicans, would be displaced due to the rising waters, and the salt water from the ocean could leach into our freshwater supplies, leading to contamination. And now, this is only the start. And the moon is getting closer and closer. While we wait for that to happen, and cause even more destruction, you might be asking, has this ever happened before? Well, to investigate, we sent our correspondent Rose to find out more.
This whole scenario got me thinking. How do we know that the moon affects our tides so much? Maybe in order to understand that, we need to look at Earth's past. First, I'm talking 4.5 billion years ago. Let me show you what I mean. I'm here at Western University to talk to Dr. Gordon Osinsky, one of Canada's leading lunar researchers, to get some answers. So, has something like this happened on Earth before?
An object the size of Mars that we now call Fair impacted Earth just after our planet formed. We actually think that this is how the moon formed in the first place. The Earth formed the other planets of the solar system formed, but also some other planets that now longer exist. And for reasons that we don't know about, one of these called the came close enough that it hit Earth, and out of this cataclysm, the Earth essentially reformed, and then the moon formed out of the disk that was present around the Earth.
How do we know that they hit Earth in the past? It was so long ago.
One of the biggest bits of evidence that we have is actually thanks to the Apollo mission. Things that we keep learning from the Apollo missions is from the samples that the astronauts brought back, and when geologists first started looking at these samples, they realized that they're really similar to rocks we have on Earth. And some places, sometimes identical, and so this really tells us that the moon and the Earth formed out of the same starting material. And we actually have samples of the moon here on Earth, and actually here in the lab, that we can take a look at, and we'll see that actually, the properties and what these rocks actually look like from the moon is very similar to the rocks we have here on Earth. Got the gloves on, and we're going to touch a part of the moon. This is indeed a sample of the moon. It's not an Apollo sample, but this is a meteorite. And so we actually have quite a lot of meteorites now that have come from the moon, from some impact event that kind of rejected them, and you can actually see that and this sample, because this is the original outer surface. that got a bit weathered in the desert of West Africa, and then we've kind of cut this sample to reveal the inside, so in a way the moon is already clashing into the Earth and hitting it, but just in much smaller bite-sized bits.
Absolutely.
200 days. Okay, the moon is now just 100,000 km away from Earth. Things are only getting worse for our planet, and everyone involved tides are reaching up to 30 m high. Every city near the water will be uninhabitable. Infrastructure near these cities will completely collapse. No more subways, trains, all roads and highways will be flooded, everything. But why is this happening? Well, I think Dr. Osinski has our answer.
What role does the moon play for Earth today? So the biggest role that the moon plays on Earth is tides. You know, if you've ever gone to the coast anywhere in the world, there'd be a certain level of tide. And if there was no moon, there would be no tides, which is kind of interesting to think about on its own. So the moon essentially asserts a gravitational attraction. On the side of it facing the Earth essentially is pulling Earth's water towards it.
Let me show you a bit more of what Drinsky means. Peter talks about the tides getting higher, and this is true, but luckily this wouldn't happen all the time. As the moon rotates around the Earth, it creates two bulges around the planet, one on the side facing the moon and one on the opposite. So as the Earth rotates, and the moon ends up in different spots, the water bulges in these areas. This creates the rise and fall of tides throughout the day. Now imagine this process being exaggerated to extreme levels.
If we go back billions of years ago, and we look at rocks that were formed, in the coastal region where they were influenced by tides, we do see really dramatic evidence that the tides were substantially higher than they are at the present day. And our explanation for that is because the moon started off much closer to the Earth than it is at the present day. So it would be the very key role that the moon plays on Earth. Now that would essentially lead to its own destruction if it came any closer. But luckily for us, that's not happening anytime soon.
I've heard that the moon is actually moving away from us about 3-8 centimeters a year, but do we know why it's moving away from us?
When scientists first discovered that the moon was moving away from the Earth, they really didn't have an explanation. But it was actually the development of this giant impact hypothesis, this model of FA impacting Earth and creating the moon. It actually provides a solution because all of those models suggest that when this event happened, the moon actually formed much, much closer to Earth, and so it fits with the model that the moon started closer to Earth after it formed. And then since then has just been moving outwards, slowly but surely over the last 4.5 billion years. But don't worry, this won't have any significant effect here on Earth, at least not right away in about a century. The days will get about 2.3 milliseconds longer. And in millions of years, our ocean tides might get slightly affected.
But unfortunately for us in our scenario, the moon is actually moving towards Earth. So what happens next? Well, you'd have to go to places with higher elevations. Cities like Denver, Calgary, and Mexico City would all be good bets. They're elevated at least 1,000 m above sea level, keeping them nice and dry from all flooding. But that doesn't mean they'd be completely safe if the flooding from our fast-approaching moon doesn't get you. Other natural disasters will. Yes, 100 days. Okay, we're now just 100 days from impact and things are only getting worse. One of the biggest things you'll notice is the changing weather all around the world. Climate patterns may completely shift, causing an increase in hurricanes and violent storms. Now weather is one thing, but what's even worse, the volcanoes and earthquakes. The moon's gravity exerts force on the Earth's crust, and if it gets closer, well, then the force increases, causing an extreme strain on the Earth's mantle, and leading to earthquakes and volcanic eruptions under this increased gravitational force. Volcanoes could erupt all over the world. The Ring of Fire along the Pacific Ocean would be particularly vulnerable. This area of the world has about 75% of Earth's volcanoes, and it's where 90% of the world's earthquakes take place, and this would only intensify with our approaching moon, with cataclysmic events happening all over the world. Everything would be getting destroyed. The cities that were safe from flooding would now be dealing with massive earthquakes, scorching volcanoes, and the moon's collision course with Earth will be happening any day now. Is there any way we could stop it? Well, there actually might be a way. In 2022, NASA ran the Double Asteroid Redirection Test, or DART for short. During this test, NASA intentionally threw a spacecraft at Dimoro, an asteroid floating around the sun. The spacecraft successfully pushed the asteroid off course, and now other researchers are building off this initial test. If humans keep digging into this research, it could change everything. Maybe it could even deflect the moon if it were to come after us. But wait, none of that might actually matter thanks to the RO limit. This is what would likely happen when our moon approaches Earth. Instead of colliding with us, our planet's gravity would overcome the moon's, causing the moon to disintegrate. T minus 0 days. Okay, the moon is now just 18,000 kilometers away, which happens to be the approximate distance of the RO limit. And this is the point where the moon starts to get heavy, affected by Earth's gravity. So instead of the moon affecting our gravity here on Earth, our planet is now starting to fight back. Due to the gravitational shift, the moon would start to rupture and break apart into pieces, ranging from tiny dust particles to asteroid-sized rocks. Now, instead of these pieces falling down to Earth and knocking down buildings or impacting the ground like the asteroid that killed the dinosaurs, they would continue to orbit and create a ring around our planet. We'd have frequent meteor showers here on Earth, thanks to the sheer volume of asteroids now floating around. And whether through gravitational force or atmospheric conditions, some of these meteors and asteroids would come raining down. Whatever animal life is left on Earth would be left extremely confused. We wouldn't be getting as much light due to the asteroid ring blocking out portions of the sun's rays. This would affect photosynthesis, both in plants and in phytoplankton. Now less photosynthesis means less oxygen. So any life that did survive would now be dealing with trying to breathe and survive with Earth's decreased oxygen level. And due to this new ring system, there would be so many more shadows cast on the planet. Some places on Earth would be extremely cold. It could get so cold that a global cooling could occur, something that may have happened before. Yeah, over 450 million years ago, a disintegrated asteroid may have formed a ring around the Earth, similar to the one we're seeing right now. This ring around the planet may have led to a global cooling event, one that dropped the temperature of Earth by 8 degrees C. A global cooling like this would cause an extreme shift in temperatures, a shift that would destroy what little food supply humanity has left at this point. And because of all these roaming asteroids and the debris right above us, our communication systems would be down entirely. If anyone else managed to survive this catastrophe, well, good luck contacting them. All satellites would be destroyed, killing our communication infrastructure. With the state that the Earth is in, with all the volcanoes, earthquakes, flooding, global cooling, maybe our best bet is just to leave here. Well, let's assume that we had the spacecraft technology to support that. If we somehow managed to get a spaceship up in the sky, well, we'd be pelted by the thousands of space rocks up in our atmosphere. This ring would be a barrier to traveling, keeping all of Earth's inhabitants inside. Say goodbye to space travel and exploration. And of course, it's safe to say that in a scenario like this, pretty much everyone would die, but this is the relative immediate future. What happens decades later, or a century into our new ringed future? Would humanity or Earth ever be able to make a comeback?
All right, well, Rose joins us in the studio now to talk a little bit more about the moon crashing into the Earth. Hello, Rose. You had a nice interview with Dr. O. Yeah, he seems to know a lot about rocks, a lot about lunar rocks. What else did you learn in your interview with him?
So basically my takeaway from this entire video is there's two worst-case scenarios, and one is a little better than the other. The moon crashes towards Earth super quick, and we're all dead. Everyone dies, as you say, on what if quite often everyone dies, or B, the moon comes towards Earth super slowly, causing more and more havoc as time goes by, which would also screw us over, but not as much as a direct impact would, and in this scenario the moon would break apart into a bunch of pieces when it reaches the RO limit, creating a potential ring around the planet.
H, if we do end up having a ring of moonbits around the Earth and we are still alive to view it, number one, how cool.
Yeah, that would be so sick.
That would be so sick. Number two, H, it would be dangerous.
How we don't know how long it would take for all that moon debris to settle into that ring formation around the equator. Right, so eventually, and we don't know how long that would be, it would look like the rings of Saturn, but initially it's going to a bunch of debris floating around. It's not going to go into the equator.
So it's all rocks all around the Earth, killing all our satellites.
Exactly, and by the time it forms into a ring, it could be tens of thousands, hundreds of thousands years. We don't know how long that would take. Like, having all of these debris floating around Earth would also cause so much havoc on Earth, it would completely change our climate. It could potentially cause another ice age, I would imagine, because if it's blocking out the sun at various times, if super huge debris is moving around and a lot of the sun gets blocked, and it creates a disturbance in our atmosphere as well, it would cause such a disruption and all of the ecosystems would have to change or die.
So, with an ice age happening, debris falling from this ring, how are you surviving this scenario, Peter? I'm probably not surviving. Depending on how many rocks you say are falling down, I don't know. You know how often and how intense it would be. I would probably dig a bunker underground.
You would dig a bunker?
Well, I'd have somebody dig a bunker for me. I don't imagine it would save me from, a 1 kilometer wide asteroid that's going to hit Earth. But at least in the meantime, I can be down there watching my YouTube videos, drinking my light beer, making macaroni and cheese. I mean, there's a chance humanity could survive if we all lived in bunkers underground for a little bit of what's left of humanity. At least if you could bring only 5 people to live in this bunker you dig with you. Who would you bring? Well, right off the top of my head, my mother, my wife, probably my 2 kids depend on how they're acting that week. And 5th, my neighbor Tom, because he's very good at survival stuff. What about you?
You have 5 people that you would take 5 people. My parents, my cat, maybe 2 of my best friends.
Yeah, we want to know what you think. So would you rather be killed instantly and painlessly, or possibly painlessly, or would you like to watch the moon come at you for a year straight, knowing that you're going to die, and then when it hits you, everything changes, and you have to work very hard to revive society? For me, it's an easy choice, but maybe you have a different point of view. Tell us below in the comments, regardless of what would happen. It's safe to say that a scenario where the moon falls to Earth is virtually impossible. Remember, the moon is actually moving further away from us every year, and the gravity from Earth pulling it in is just too strong, making sure the moon stays in a stable orbit. And as cool as an asteroid ring around Earth might be, I'd rather keep our oceans and have way less active volcanoes. But that got me thinking, could there be a scenario similar to this? What if Mars decided to head toward Earth? Well, that sounds like a story for another What If